Completing the square. The process of completing the square is one way to solve quadratic equations and works particularly well when they are in a form similar to this one down here. We'll get into the details of that form soon. What it means to complete the square just on an expression is to add a term to make it into a perfect square trinomial. So in this case, because we have a leading coefficient of 1, which is a really important part of this, all I need to do is take the coefficient of the linear term, that is the x to the power 1 term, divide it by 2, and then square it to get the number that I add. So in this case, if I take 10 and I divide by 2, I get 5. If I then square 5, I get 25. So 25 is the number that I want to add to this expression to make it into a perfect square trinomial. Now recall from factoring that what a perfect square trinomial is a trinomial that factors as the square of a binomial. So the way we can figure out what these two pieces are is the first term is what I would square to get the first term in my trinomial. So my first term is x in order to get x squared. My last term is what I would square to get the last term in my trinomial. So my last term is a 5. And finally, the sign in the middle should match the sign of the middle term. Since the middle term is positive in this case, plus 10x, we have a plus in our binomial. We can do a quick check off to the side here just to make sure that x plus 5 squared really is equal to x squared plus 10x plus 25, and to do that we would use FOIL. Okay, so we can see by FOILing this out that it is in fact equivalent, that x squared plus 10x plus 25 is a perfect square trinomial that factors as x plus 5 quantity squared. The way we use this to solve quadratic equations is first we get our x terms together on one side of the equation, and then we leave a little space. And we get our number terms, which have no x in them, over on the right if necessary, and put a space after it too. It's very important to leave that space, otherwise it can feel a little bit lost what to do in the next step. Alright, now what we do is we complete the square on the left-hand side using that same system that we just talked about. We're going to take the middle coefficient, which is 4. Doesn't really matter whether you bring the sign with it or not, so it's easier not to. After squaring, it's always going to be positive. We'll take this 4, we'll divide by 2, and then we'll square. That's supposed to look like a square. And we'll put the result here. So 4 divided by 2 is 2. 2 squared is 4. I'm going to add 4 to the left-hand side of this equation. So I have to add 4 to the right-hand side as well, just to make sure I haven't changed the equation. I add this number to both sides of the equation. Forgetting to add it to the right-hand side is a fairly common mistake, so be careful with that. Okay, now I'm ready to see what I've got. I'm just going to rewrite this whole thing to make it look a little bit easier to read. On the left-hand side, we've got x squared plus 4x plus 4. And on the right-hand side, we have 5 plus 4, which is 9. At this stage, we now have a perfect square trinomial over here on the left, and we can factor it or write it as the square of a binomial. Factoring that, we would get x is what I would square to get x squared. 2 is what I would square to get that last term of 4, and the sign of the middle term is a plus, so the sign of our binomial is also a plus. The right-hand side does not change during this step. We now have an equation that we can solve by the square root property. The whole point of completing the square was to get it into this form of a squared expression is equal to a number. Now we can apply the square root property to set up two simple equations, x plus 2 equals the square root of 9, or x plus 2 equals minus the square root of 9. And of course the square root of 9 is 3, so this becomes x plus 2 equals 3, x plus 2 equals minus 3, carefully subtracting 2 from both sides, then gives us x equals 1 and x equals negative 5. So we got two solutions to this equation, and while it's true that this equation could also have been solved by factoring, this process works on equations that cannot be solved by factoring. So this still works when we get irrational solutions, which is one of the reasons it's a valuable method. One thing that I want to emphasize about it is that for this rule that we established here to work of divide by 2, then square, the leading coefficient must be a 1. If you had a leading coefficient other than 1, you would have to divide both sides of the equation by that leading coefficient in the first step. And we're not going to do any examples like that in this particular video because those equations can get a little bit messy and they involve a lot of fractions by the time the whole process is done. This next equation cannot be solved by factoring, so we know that it has irrational or imaginary solutions due to the fact that we can't factor it, but it can be solved by completing the square. Keep in mind that because the solutions on this one are not going to be rational numbers, the very end of it's going to feel a little bit different from the one that we just did. Still, I suggest that you pause this recording and work the problem out yourself first, see how far into the process you can get, and then play the recording and compare what you did with ours. As in the previous example, my first step is going to be to move the number term to the right-hand side to get it away from the x terms in this equation. So we have x squared minus 8x, then we leave a space, we have our equals, then we have our negative 5, and then a space. To decide what number to add to both sides, I take this coefficient. Again, the sign doesn't matter at this stage because by the time I square it, it's going to be positive regardless. I divide by 2 and then square. And I put the result here. So 8 divided by 2 is 4. 4 squared is 16. I'm going to put 16 plus 16 in this space. And of course, remember to add that 16 to both sides. Now I'll go ahead and write the factored form of the left-hand side. This factors as x minus 4 squared. Don't forget that the sign in your binomial matches the sign of the middle term of your perfect square trinomial. And over here on the right-hand side, negative 5 plus 16 is 11. So when I go into the square root property, I get x minus 4 equals the square root of 11, or x minus 4 equals minus the square root of 11. Because 11 is not a perfect square, we're not going to be able to get rid of that square root symbol. It's still going to be in our final answer. I'll add 4 to both sides. Again, always pay very close attention in this step to the fact that these are not like terms. There's no way we can combine this 4 and this square root of 11 into a single term. All we can do is write it as a sum, 4 plus square root of 11, and x equals 4 minus the square root of 11. Either order is okay. It's okay if we write this as negative square root of 11 plus 4, but it's a little bit more standard to put the irrational term, the term that's still inside a square root, last. Part of the reason for that is that the quadratic formula is set up to put the terms in that order.